equations. I believe it's from sections chapter 6, section 6.1, 6.2, and part of 6.3. These are the topics that I will cover today. Systems of two linear equations and two variables. I believe this is 6.1. The first topic will be determine whether an ordered pair is a solution to the systems of equations. And then solving by graphing method, substitution method, elimination method, and how these type of problems are associated with real-life situations. And then the largest instance of equations is from section 6.2. There's the elimination method, matrix method, and 6.3 is how these problems are applied in the real-life situation. So let's start with topic number 1. Topic number 1 states, determine whether the given order list of numbers is a solution of the systems of equations. So number 1, they're going to give you an ordered pair, which is negative 1, 3. So what we have to do, right, we're going to plug in negative 1 for every x and 3 for y. So these are two equations, so let's call it equation 1 and equation 2. So one thing that we have to know is for this order pair to be a solution to the systems of equations, it's going to make both equations true for number 1 and also for equation number 2. If on one of them is true, but the other one is false, then it's not a solution. It has to meet the requirements for both. Okay, so let's start with equation number 1. Okay, so I'm going to plug in negative 1, right? Negative 1 for x and 3 for y. So x is negative 1 and y is 3. Now we get to evaluate it. So 2 times negative 1 plus 3 will give us negative 2 plus 3. This gives us 1 equals 1, right? So this is true for equation number 1. But it also has to be true for equation 2. So there's equation 2. I'll repeat the process. I'm going to plug in negative 1 for x and 3 for y. This gives us 3. 3 plus 6 is 9. So this is also true. That means that the order pair negative 1, 3 is a solution to the systems of equations. Okay. Now let's do the same thing for number 2. We have x is 2 and y is negative 0.5. So again, there's two equations. So let's call it equation 1 and equation 2. So we start by plugging in 2 negative 0.5 to equation number 1. So x is 2 and y is negative 0.5. This gives us 1 minus 4. 1 minus 4 is equal to negative 3. So negative 3 equals to negative 3. So it works for equation number 1. But it also has to satisfy equation number 2. Again, we repeat the process. 2 for x and negative 0.5 for y. This gives us 2 minus 2.5 will give us negative 0.5. If you notice, these are not equivalent. Therefore, the point 2 negative 0.5 does not make both equations true, then the order pair is not a solution. So for number 1, it was a solution, and for number 2, it wasn't. Okay. Now we're going to be doing systems of two linear equations and two variables. We're going to be using the graphing method. This is like the concept of what it is to find. It's either going to be one solution, which is figure A. Figure B is going to be infinite solution, which is a line on top of a line. And figure C, it means that they're never going to intersect. So that's called. Okay, now let me give you some characteristics of how each one of these, A, B, and C, are going to look. Okay. Now, if it's one solution, when you're using when you're using the elimination method or substitution method, if you get x equals to a number like x equals to a or y equals to b, then it's going to be one solution. Okay. And this is called, for example, if you get x equals 3 or y equals negative 2, it means there's going to be one solution. This is called, and then for B, it's called infinite solutions. And how it looks like, if you get something like A equals A, right, there's no variables, just a number equals to a number. And if it's true, then it's going to be infinite solutions. Example, if you get something like 3 equals 3 or 0 equals 0 at the end with no x's or no y's, then it's going to be infinite solutions. And I can put there on the bottom, there's no y nor x. Now for C, If you get also no variables, no x, no y, you have something like a equals to b. Example 3 equals 4, or right, there's no solution because 3 does not equal 4. That means there's going to be no solution. Okay, if you have one solution, it's going to be called consistent independent system. If you have infinite solutions, it's going to call consistent but it's dependent system. And if no solution, it's going to be called inconsistent system. Okay, let's do some examples of these. For example, this is number 3. Solve the system by graphing. I'm going to solve this very same system in 3 ways: by graphing, by substitution, and the elimination method. Let's first do it by graphing. So by graphing, I'm going to graph both equations. Remember, guys, I believe in chapter 2, where you graph, you have to put it in the form y equals to mx plus b, and the m is your slope, which is 3. It's going to mean, right, and the y, or the b, which is a y-intercept, will be, the b is -6, which will be 0, -6 for the y, and that's your starting point. So we start at 0, -6. It's going to be down here. Then we're going to go up 3, 1, 2, 3, and 1 to the right, and we connect the points. That's a line for equation number 1, for y equals to 3x minus 6. Now, we have to do the same thing for equation number 2. For equation number 2, right, for now, we have to put it in the form y equals to mx plus b, which is a slope-intercept form. Right, so we need to solve for y. So here we're going to add 5x to both sides. So we're going to get -2y equals to 5x minus 10. Then we're going to divide everything by -2. Right, so divide everything by -2, we get y equals to -5 over 2x plus 5. Now my slope here will be -5 over 2. And my b is +5, right? Which is a y-intercept will be 0, 5. So 0, 5 is my starting point. Okay, I repeat. Always the b in the equation will be your starting point. Okay, but you write it as a y-intercept, which will be 0, 5. So 0, 5 is up here on the positive side for the y, right, where the point is. Now we're going to go down 5 and right down 5 because it's negative, and 2 to the right. 1, 2, 3, 4, 5, and 2 to the right gives us the point 2, 0. We connect the points, and that's equation number 2. So the solution is where both lines intersect. So the answer is 2, 0. That's my solution. Okay. And again, when you have a solution, it's called consistent independent system. So that's how you graph. Okay, I believe by now you guys should know how to graph because graphing was in chapter 2, and we already in chapter 6. But if you don't know how to graph, still, you can always go for tutoring, online tutoring, or on campus tutoring. They will help you how to graph. Now come to the very same systems, right, of equations, but we're going to do it by substitution. Again, let's call it equation 1 and equation 2. Okay, here's the solution, guys. When they give you two equations, right, and you're doing it by substitution, you're going to have to isolate either the y or right, and then plug it in. Plug in the value for x or for y, plug it into the other equation. So in this form, right, how it's set up, in equation 1, the y is already by itself, or the y is already isolated. So then we're going to substitute the value for y, which is 3x minus 6, into the y in equation number 2. Okay? So we're going to plug in 3x minus y, and I like 3x minus 6, and I like to use color code. That way students can see exactly what happened, right? So I'm going to plug in for y is 3x minus 6, so I'm going to plug it in for the value of y. Now I use the distributive property. So we're going to get negative 5x, and then we're going to multiply negative 2 times 3x and negative 2 times negative 6. And this is the result. Negative 5x minus 6x plus 12 equals to negative 10. Now on the left side of the equal sign, we get to simplify the left side by combining like terms. So here we have negative 5x minus 6x will give us negative 11x. So we have negative 11x plus 12 equals to negative 10. Now we're going to have to send the positive 12 to the right side by doing the opposite, which is addition. So we're going to do subtraction. So subtract 12 from both sides. If we do that, it's going to give us negative 11x equals to negative 22. Right? Then we divide both sides by negative 11. The result is x equals 2. So now we found the value for x, but remember, the solution is going to be an ordered pair, which means it has an x value and a y value. It's going to be a point. So now we have to go back to either equation 1 or 2. It doesn't matter which one, and plug in the value 2 for x and solve for y. So it's up to the student which equations they want to use. Okay, in my opinion, equation 1 is easier because the y is already by itself, right? It's already isolated. So I'm going to plug in 2 for x, right? And then we're going to simplify. This will give us 6 minus 6, so the answer is 0. So when x is 2, y is equal to 0. So that's my answer, 2, 0. You see, because we got the same thing as when we solved it by graphing. Now, let's do it another way. And again, it's called a consistent independent system. Let's do it by the elimination method. In order to apply the elimination method, it has to be in the form ax plus by equals c. It has to be in that form. Okay, I believe this form in this book, the one that we're using, they call the rule. But in other books, this can be called in general form. Okay, so anyway, you have to put it in this form ax plus by equals c. If you notice, equation number 1 is not in that form. It needs to be rewritten in proper form. So we're going to subtract 3x to both sides. That will give us negative 3x plus y equals to negative 6. Now it's in proper form. So equation 1, right, we rewrote it as negative 3x plus y equals to negative 6. And we just bring down equation number 2. Okay, now here, like I tell my students, right, it's up to you what's best for you, for the student. You have to get rid of the y's or the x's. That's why it's called the elimination method. This method is also called the addition method. Okay, but in this book, they call it the elimination method. So we have to eliminate the x's or the y's. Okay, here, what I see, right, it's easier to eliminate the y's because the y in equation 1 is isolated. It's by itself, right? There's no coefficient in front of it, which means it's a 1. So here, guys, we're going to get rid of the y's by multiplying every term in equation 1 by 2. And why 2? Because 2 times y will give us 2y. Then when I add it to the second equation, they'll be eliminated. But we have to multiply 2 times every term. So 2 times negative 3x will give us negative 6x. 2 times positive y will give us positive 2y. And 2 times negative 6 will give us negative 12. So equation number 2, we'll just let it over. And now all we do is add them vertically. So negative 6x minus 5x will give us negative 11x. And the y's are going to cancel, right? They're going to be eliminated because 2y minus 2y will give us a 0y. And then we add the constant, which is negative 12 minus 10 will give us negative 22. This is my result. Then we divide both sides by negative 11. So x equals 2. Once you get to this stage, for substitution or the elimination method, once you get the value for x or for y, then you do the same process for each method. So in this case, right, we already found the x. Now we need to find the y. And again, it's easier to go back to the original equation number 1 and plug in the 2 for x, which will give us, again, it was going to give us 0. So the solution is 2, 0. And again, it's called consistent independent system. Check it out, guys. I'm going to do it again. This very same problem, but now instead of eliminating the y's, I'm going to eliminate the x's, just so you see that it's a little bit more work, okay? So again, same thing, repeat the process. I need to put it in the form, right? In ax plus by equals c. So again, this is the same thing as the previous slide. Subtract 3x to both sides. So this is equation 1 in the correct form. But instead of eliminating the y's, I'm going to eliminate the x's. So to eliminate the excess, right? See, these are both negative, right? So I need to multiply one by a positive. So you multiply the equation 1 by the coefficient on equation 2, right? Which is -5. And then I'm going to multiply equation number 2 by 3. Why 3? Because -3 times -5 will give us a positive 15. And -5 times positive 3 will give us a -15. Then when I add them, they'll be eliminated, okay? So again, I need to multiply 3 by every term in equation number 2. So this is the result. -15x minus 6y equals to -30. Now I get to add them, right? So the x's are going to be eliminated. Why? Because 15x minus 15x will give us a 0x. -5y minus 6y will give us a -11y, and 30 minus 30 is 0. We divide both sides by -11. So the result is y equals 0. Now I go back and plug in 0 for y, another equation. This time I'm going to use equation number 2, right? It doesn't matter what you use, but I'm going to use equation number 2. So then I'm going to plug in 0 for y. This gives us -5x equals to -10. Then we divide both sides by -5, and the result is x equals 2. So that's my solution. Choose 0, and it's called consistent independent system. So it doesn't matter what approach you use. Okay, it doesn't matter. I just proved it to you that you can get rid of the x's or the y's. It doesn't matter. So as you do more problems, you're going to become familiar, and then you're going to notice that one method will be easier than the other. But every student thinks different. Okay, we don't think the same. For some students, one method might be easier, and for other students, the other method might be easier. So you do whatever is best for you. Okay. Okay, now this is number 6. Okay, now remember, guys, here I'm going to get rid of the x's. So I'm going to multiply equation 1 by -2. Why -2? Because -2 times 3 will give us -6. Okay. -6, and then -2 times -2 will give us positive 4y, and -2 times 4 will give us -8. And equation number 2, we'll just let it over. The result is 0 equals 0. Remember when I mentioned, guys, when I was going over the graphs, and I tell you there's characteristics. For example, this will be infinite solutions, which means that both lines lie on top of each other. Remember I said that you're not going to have no more variables, no x's or y's, and the number on the left is equal to the number on the right, right? So this is infinite solutions. And this is called consistent dependent system because it's dependent because the y depends on the x. Okay. Now number 7. Okay, again, I'm going to get rid of the x's. I'm going to multiply by -3, equation 1. So -3 times 2x will give us -6x. -3 times positive 5y will give us -15y. And -3 times 8 will give us -24. Equation number 2, we just bring it over. Right? So once we add them, it's going to give us 0 equals to -6. If you notice, there's no more variables, no more x's or y's. So this means this is not true, right? Which means this is no solution. It means that the lines are parallel. They will never cross. Okay? And this is called inconsistent system. Okay, now let's move on. Okay, now here's how you apply these type of problems in a real life situation. Okay, for example, I believe this is one of the homework from this chapter here, from this section. It says, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? I always tell my students that this is a strategy. We're going to put people with people, right? I need to find two equations. I'm going to put people with people or seats with seats and money with money. What does that mean? Okay. It means that, for example, I'm going to let X equal to adults, to the adult seats and let y equal to the children's seats. You see, so x number of adult seats plus y number of children's seats equals to 200 because there were 200 total seats. So equation number 1 is x plus y equals to 200. Now for equation number 2, right, we're going to use money with money. If you notice, all right, the ticket for adults is $8. And adult tickets is represented by the variable x. So this will give us 8x. Now, for the children's tickets, right, they're $5, and children's tickets is represented by y. So this will give us 5y. And what was the total revenue or the total income? Was $1,435. That's how we get equation number 2. So it's going to give us 8x plus 5y equals to 1,435. So we have both equations. Now you can do it any way you want. Again, in my opinion, guys, it's not good to do it by graphing because graphing the numbers are too high. So graphing is out of the question. We can do it by substitution. But for substitution, we have to do a little bit more work. If this is like a hint that I tell my students, if it's already in the proper form to do the elimination method, well, then do it that way. For example, x plus y equals 200 is in the form ax plus by equals c. And equation number 2, 8x plus 5y equals to 1,435. It's also in the form ax plus by equals to c. So we're going to use the elimination method. Again, equation 1 and equation 2. So then here, guys, it doesn't matter what you want to get rid of. They're both as the same, because the x on equation 1, right, is there's a coefficient of 1, and also for the y, right? But you don't see it, right? We don't see it, but we know there's a 1 there. So here, guys, I'm going to get rid of the x's. I'm going to multiply equation 1 by -8. Again, why -8? Because -8 times x will give us -8x. Then when we add them, they'll be eliminated, because -8x plus 8x will give us a 0x. But I need to multiply -8 times every term or times both sides of the equal sign. That gives us -8x minus 8y equals to -1,600. Equation number 2, all we do is slide it over. Now we do the operation, right? We add them. So it's going to give us -3y equals to -165. We divide both sides by -3, and the result is y equals to 55. I found the value for y. Now I need to find the value for x. Okay, now here you can go either equation 1 or 2. But if you notice, equation 1 is much simpler to work with. And equation 2, you see it's a little bit more complicated because the numbers are bigger. So let's take to equation number 1. Okay, so we know the value for y. Now I'm going to plug in 55 for y. So we're going to subtract sides. So we get x equals 55. So x is 145 and y is 55. But what are they asking here? Right? They're asking for how many adults and how many children were in the audience. So we have to go back, right? So we know that x represents adults. So it's going to be 145 adults and 55 children were present at the theater. Okay? So that's how we work real life situations with solving systems of equations. Okay, now this is 6.2. Linear systems, right? Larger systems of linear equations. So here, guys, you're going to have 3 variables, x, y, and z, and a constant. Now, this is the plan that I tell my students, right? I was trying to come up with a plan for them, something that they know how to, like, for example, at times they see like a system of equations with 3 variables, and they kind of freak out because they don't know what to do. So I always try to come up with a plan. Okay? So the plan here, guys, is you always want to have a coefficient of 1 on equation number 1, because the work will be much easier. So at the beginning, you can rearrange them. Okay? And I can put here, rearrange a possible coefficient of 1 on the x being equation 1. So I'm going to switch equations 1 and 2. Equation 2 will be number 1, and equation 1 will be number 2. Okay? Now here's a plan. What's a plan, right? So here's a plan. I'm gonna do equation 1 and equation 2, and I'm gonna get rid of the x's. Right? For both of these, I'm gonna do equation 1 and equation 1 and 2 and 1 and 3, eliminate the x variables. Then you're gonna get two more equations with no x values on both. Right? We're gonna call it, when I do equations 1 and 2, I'm gonna call it new equation 2. And when I do 1 and 3, I'm going to call it new equation 3, right? These equations are not going to have no x variables because they were eliminated. So now I'm going to get the new equation 2 and the new equation 3, and I'm going to eliminate the y's. After I do that, I'm going to get a new equation, which will be something like z equals to something, to a number, right? And c can be any real number, right? So then I'm going to go back and substitute. After other steps, the equation should look like this. You see? So I'm going to show you how we get it like this, guys. Okay? Here we go. Let's go to the next slide. And then we're going to back substitute. Here we go. So here, guys, I'm going to do the same thing as what I did earlier. We're going to do the elimination method. So I'm going to get equations 1 and equations 2. Right? This is the reason why they want a coefficient of 1 on equation 1. Because this way, we're going to use equation 1 to eliminate the x's on equation 2. You see, it'll be much easier. So I'm going to multiply equation number 1 by negative 2. And again, why negative 2? Because negative 2 times x will give us negative 2x. Then when we add it to equation 2, the x's will be eliminated. Okay? So after I multiply negative 2 times equation 1, this is my result. Negative 2x plus 6y minus 4z equals 0. And we just bring equation number 2 over. So you see, guys, the x's were eliminated. So this is my new equation 2. Now I'm going to repeat the process and do it for equations 1 and 3. So I'm going to multiply equation 1 by negative 3. Okay, that's my result. We just bring over equation number 3. After we add them, the x's are also eliminated. So this is called my new equation number 3. Now I'm going to get the new equations 2 and 3, and we're going to eliminate the y's. Okay? A lot of, at times, they say, what's the least common multiple between 4 and 10, right? Which is 20. But at times, students, they don't know what that means. So instead, eliminate the y's. I'm going to get the coefficient, right, on equation number 3 and multiply that by equation number 4. By equation number 2, and vice versa. But if you notice, the original, we have positive 4y and positive 10y. That means that one of these has to be multiplied by a negative number. It doesn't matter which one. Here I chose equation number 1 because negative 10 times 4 will give us negative 40. And 4 times 10 will give us positive 40. So they'll be eliminated. But you have to multiply the negative 10 times every term in equation number 2. And you have to multiply 4 times every term on equation number 3. So this is my result. 2z equals to negative 2. Now we divide both sides by negative 2, and we have the value for z. Z equals negative 1. Remember, guys, that's how the equation looked. Here, right, we keep equation 1, and we know we keep equation 3, right, as equals to negative 1. But equation number 2 can be either the new equation 2 or the new equation 3. It doesn't matter which one. But I always keep the new equation 2. Okay? Okay, now we're going to back substitute. So I'm going to go to number 2, equation 2. I already know, right? We already know the value for z. So we're going to plug in negative 1 for z and solve for y. Right? We subtract 3 to both sides. And for y equals 0, so we divide by 4, so y equals to 0. You see, I already have the values for z and for y. Now I'm going to go back to equation number 1 and plug in the 0 for y and the negative 1 for z. And this way, we're able to solve for x. Y is 0, and z is negative 1. This gives us x minus 2 equals 0. We add 2 to both sides. So this is my solution. X is 2, y is 0, and x is -1. I mean, x is 2, y is 0, and z is -1. That's my solution for this equation. Now, there's also another way to solve the system is by matrix. Okay. Now, this is called the Gauss-Jordan elimination method. This method is a little bit challenging for students. At times, you have to really understand what you're doing, guys, to be able to solve it this way. I'm going to show you the plan, how we can actually solve it, and only with 3 steps. Okay, because most instructors and also most of the books, they do 1 step for each matrix, which would take like a whole page, even more, of solving this. Solving this problem. But the way I do it, I kind of modified it, and we can do it in 3 steps. Okay. Well, let me show you what the plan is. This is called the linear systems of equations. I have to convert it to augmented matrix, and then I'm going to go to RREF. Okay, now this is a system of linear equations, right? It's going to be x minus 3y plus 2z equals 0, 2x minus 2y plus z equals 3, and 3x plus y minus z equals 7, right? So I'm going to convert it to augmented form. I'm only going to get the coefficients, right? This will be 1, -3, 2, and 0. Now, equation number 2, this will be 2, -2, 1, and 3. Equation number 3 is 3, 1, -1, 7. Okay, this is called augmented matrix. So I went from linear systems of equations to augmented form. Now, the RREF stands for reduced row echelon form, which means I'm gonna go from linear systems to augmented, and this is what it means by reduced row echelon form. This means that these are the x's, these are the y's, these are the z's of the systems, right? So this means 1x plus 0y plus 0z equals 2. In other words, x equals to 2, y equals to 0, and z equals to -1. But how are we going to do this? Okay. Okay. Now, I call it the 3-step plan. Okay. At first, I'm going to show you just the concept with all letters. Okay. So we have to go from here to here, right? With 1, 0, 0, 0, 1, 0, 0, 0, 1, and x, y, and z. Okay. The first step, I have to make the E and the I equal to 0, right? Because it's color-coded, it's in blue. Right, so step 1, I have to make the E and the I equal to 0. So row 2 is going to change because the E has to be a 0, and also row 3 is going to change because the I has to be a 0. After you execute step 1, this is what you should see. Okay, I also changed the letters here, guys, right? Because you will not get the same letters after the first step. Now, step number 2 is in green. So the B and the Q must be zeros, right? So that's why equation 1 is going to change because the B has to be a 0, and equation 3 has to change because the Q must be a 0. So after I execute step 2, this is how it should look. Okay, now step 3, I'm going to do it in red, which means the U must be a 0, right? Because over here on top, it's in red also to match, to color code it, and the N must be a 0. So after I execute step number 3, you should see something like this on your matrix. And again, I put here, simplify if possible as you do each step, which I'm going to show you how all this is done. So this is how it should look after step 3. You notice step 1, step 2, step 3. At the most, we're going to do 4 matrices, but most of the times it only takes 3 if you follow this method. And again, the book does a little bit different, and but I kind of modified it. I use the same Gauss-Jordan method, but I modified it to be kind of simpler. Okay. So anyway, at times students get confused with all the variables. With all the letters. This way, at times I just use number signs, right? I'm going to repeat the same thing, but instead of using letters, because students kind of freak out with letters, because I used to be like that too when I was in going to college. back in the 2000s, I used to get like, not scary, but I used to get confused with too many letters. There was X, Y, and Z, and then A, B, C, and all that stuff. That's why here I like to show for the students that it means the same thing as with letters. So this is a concept here, right? So now I'm going to use number signs instead of letters. So first step, right? Repeat the process, but now the x's on row 2 and row 3 must be zeros. Step 2 will be the y's, right? The y's column. And step 3 will also be the same thing as the previous slide. Okay, let me go back real quick. So again, you see same thing, but this way, because a lot of students, like I said, they don't understand letters in math. That's why you just put the number signs. This way, nobody gets left behind. Now, this is a three-step plan in action. Okay. So again, I believe it's the same matrix that we solved earlier. So this is how it should look after we're done. You can also plug this in the calculator. If you want to know how to plug it in the calculator, guys, to get the answer, we can show you. Maybe go to tutoring, or maybe you can get a hold of me and I can show you how to put it in the calculator, guys. But with my students, I do show them how to put it in there. It will take you about maybe about a minute to get the answer. But in the exams, I always want to see the work. Okay, if no work, no credit. But at least you know how to check your answer in the calculator. Okay, now, so again, that's row 1, row 2, right, and row 3. So step 1, I'm going to put it in blue. So step 1, the 2, right, where the 2 is, okay, I forgot to tell you one thing. In step 1, we keep row 1. In step 2, we keep row 2. In step 3, we keep row 3. You see, it's all like kind of synchronized, kind of there's like a pattern for this. So then the 2 in row 2 must be a 0. So I'm going to put it in blue. And also the 3 in row 3 must be a 0, right? To finish step 1. But now we're going to be using row 1. So here we go. I'm going to multiply -2 times row 1 and add it to row 2. Right? Because -2 times 1 will give us -2. And then when you add it to row 2, they'll be eliminated. And also I'm going to multiply -3 row 1 plus row 3. And here's my work. Right, so -2 row 1 is equal to -2, right, times 1, -3, 2, 0. It's going to give us -2, 6, -4, 0. Then I'm going to add it to row 2. Row 2 is 2, -2, 1, and 3. Right, so after we do the operation, it's going to give us 0, 4, -3, 3. That's my new equation number 2. Now let's do the second part. -3 row 1 will give us -3, 9, -6, and 0. Plus row 3, right? We just bring it over. It's going to be 3, 1, -1, 7. After we do the operation, it's going to give us 0, 10, -7, 7. That's my new equation 3. Okay. Now on the next slide, I'm going to do step number 2. So I'm going to carry this whole thing here, guys, on the next slide, right? You see, so I got how the second matrix should look. That was after we completed step 1. And again, I put here on top, also with the color coded, then now we're going to be doing step 2, which means we're going to use the green color to represent step 2. So for step 2, we keep row 2. And then the negative and the 10 must be zeros. So that's why I'm going to do some operation in row 1. The 10 on the third equation has to be a 0. That's why we have to do some kind of operation or some kind of work in row 3. So now we're going to be using, right, the 4 here, right, on equation number 2. This is the hardest it gets because I have to multiply both rows by a number. So I'm going to multiply row 1 by 4 and row 2 by -3. Okay, 3 row 2 plus 4 row 1. And here, right, similar here, I'm going to multiply row 10 times -10 times row 2 plus 4 row 3. And here's my work. So 3 row 2 plus 4 row 1, I multiply 3 times every term there, so it's going to give us 0, 12, negative 9, 9. And plus row 1, right? So multiply 4 times 1, negative 3, 2, 0 will give us 4, negative 12, 8, and 9. After we add them, it's going to give us 4, 0, negative 1, and 9. That's my new equation number 1. Now I'm going to do the next step, right? Negative 10, row 2 will give us negative 10 times 0, negative 10 times 4, negative 10 times negative 3, and negative 10 times 3 will give us 0, negative 40, 30, and negative 30. Plus 4 row 3, right, is going to give us 0, 40, negative 28, and 28. After we do the operation, it gives us 0, 0, 2, negative 2. Because remember when I mentioned about the plan that I mentioned, I would simplify as we go along to eliminate extra matrices. So here, right, is a good example that we're going to simplify. We're going to divide every term by 2, right? So it's going to give us 0, 0, 1, negative 1, because 0 divided by 2 is 0, 0 divided by 2 is 0, 2 divided by 2 is 1, and negative 2 divided by 2 is negative 1. So this is my new equation number 3. If you notice, there's zeros here on the first column for the y and the z. There's zeros here on the second column for the x's and for the z's. So the last step, we have to get rid of the negative 1 and the negative 3 on column number 3. Okay, so let me go to the next slide and we'll do the last step. Right, so step 3, the negative 1 must be a 0. Again, step 3, we're going to keep row 3. I forgot about that. And we're going to use row 3. So the negative 1 must be a 0. So we have to execute some type of work here on equation number 1. And also the negative 3 must be a 0. So we have to do some type of operations on equation number 2. So we're going to be using, right, equation number 3. If you notice, equation 3 is 1, right, for the z's place, and it's a negative 1 on row 1. So we're going to just add row 3 plus row 1. To get rid of the negative 3, I'm going to multiply 3 times row 3 and add it to row 2. And here's my work. Row 3 plus row 1 will give us 4, 0, 0, 8. That's my new, right? And we can simplify. We can divide everything by 4. So it's going to give us 1, 0, 0, 2. That's my new equation number 1. Now, for the second step, right, we're going to multiply 3 times row 3, which will give us 0, 0, 3, negative 3. We're going to add it to row 2. This will give us 0, 4, 0, 0. We can divide everything by 4 because the objective is to have 1s all the way across. That gives us 0, 1, 0, 0. And that's my new equation number 2. If you notice, so this is my solution. It's going to be 2, 0, 1. X equals to 2, y equals to 0, and z equals to negative 1. Okay, now, I know that for some students, this is kind of hard to take everything, right? But but what you can do, if you need a copy of this PowerPoint, I'll send you the PowerPoint. Just send me an email at the end. And this is what I do with my students. I give them the PowerPoint. I first explain it, and then I tell them to go do it at home. Go do a problem, right, from the homework, and then just follow my steps. And they have told me that this is a wonderful, PowerPoint, because they tell me that they can actually solve it. Okay, so I know that you can do the same thing and actually do some of the homework and actually solve it this way. Now let's do one from the homework, right? Let's work together here. Again, step 1, we keep row 1. So the 2 is going to change, and also the negative 1 is going to change. So it's going to be negative 2, row 1, plus row 2. And we have 1, negative 1, so it's going to be row 1 plus row 3. And here's my work. Step 1, I call this step 1A and B. So step 1A, negative 2, row 1 will give us negative 2, negative 4, 2, and negative 12. By multiplying negative 2 times all the terms here. Row 2, right, we just bring it over. And then we execute the operation. It's going to give us 0, negative 5, 5, and negative 10. If you notice, this can be simplified. Right? We can divide everything by negative 5. So it's going to give us 0, 1, negative 1, and 2, and that's my new equation number 2. Now row 1 plus row 3 will give us 0, 1, 0, 1. That's my new equation number 3. Now for step 2, again, let's do it in green. For step 2, we're going to use row 2. So the 2 on row 1's got to change, right? So we got to do some kind of work there. And also the 1 on row 3 is going to change. That's why we have to do some work there. So we're going to be using row number 2. So I'm going to multiply negative 2 times row 2 and add it to row 1. Right, to eliminate the 1 in row 3, right, they're both positive, so I'm going to multiply negative 1, row 2, and add it to row 3. And here's my work. Negative 2, row 2, right, it's going to give us 0, negative 2, 2, negative 4. We add it to row 1. We get 1, 2, negative 1, 6. So after we do the operation, will give us 1, 0, 1, 2. That's my new equation number 1. Now let's do the second step on step 2. Negative 1, row 2, right? It means all the signs are going to switch on inside the parentheses. Because negative 1 times 0 will give us 0. Negative 1 times 1 will give us negative 1. Negative 1 times negative 1 will give us a positive 1. And negative 1 times 2 will give us a negative 2. And row 3, we'll just start it over. This gives us 0, 0, 1, negative 1. That's my new equation number 3. If you notice, now we only need to get rid of the third column, right? For equation 1 and also for equation 2. So we're going to be using, for step 3, we're going to be using row number 3. So it stays how it is. So the 1 on top on equation 1 is got to change, right? So we're going to do some kind of operation there. And also the negative 1 on equation 2 is got to change. It's got to be a 0. So by using row 3, to get rid of the 1 on equation 1, I'm going to multiply negative 1 times row 3 and add it to row 1. Since if we add these two, right, it will be 0, so we're going to add row 3 plus row 2. And here's the work. Negative 1, row 3 will give us 0, 0, negative 1, 1. Add it to row 1 will give us 1, 0, 1, 2. So after we do the operation, we get 1, 0, 0, 3. That's equation number 1. Row 3 plus row 2 will give us 0, 1, 0, 1. That's my new equation number 2. If you notice, it's already in proper form. All the ones diagonally are ones. I mean, all the spaces are 1, and the rest are zeros. That means x equals to 3, y equals to 1, and z equals to negative 1. That's my solution. Okay, now how do we use this in a real life situation? Okay, so here it is. Here's a word problem. This is also from the homework. Okay, it says tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total tickets receipts were $1,150. And then the second to the last, the sentence says 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Solution, right? We need to find 3 equations. So for the first 2, it's kind of simple, guys. People with people and money with money. Equation number 3 is always a little bit more challenging. Okay, so people with people. So let's take it in order. So adults is right. Adults is first. So let x equals to adults. Y is second. So teenagers be y, and preteens be z. Right. There are 570 total people. So again, people with people. So x plus y plus z equals to 570. Now money with money. So $5 for adults, right? So since x represents adults, it's going to give us 5x. Right, is represented by y, so it's going to give us 3y. And preteens, right, is z, So there's $2 for the, I mean, preteens tickets are $2, so that's going to give us 2Z. What was the total income? $19.50. So it's going to be 5x plus 3y plus 2z equals to 1,950. So we have two equations now. But guess what? We're missing one. Need 3. Now, here, guys, where it says 3/4 as many teenagers as preteens attended. Okay? So this is the way it should be, right? Why? Because they're talking about teenagers and preteens, so we know how to deal with it, y and x. This is the setup here. But students think, how on the road is that equal to y equals to 3/4z? Here's what I tell my students. If it is difficult, write it how it sounds and then flip it. Maybe the word flip it doesn't go here, okay? But let me show you what I'm trying to say when I say flip it. Doesn't it sound like 3/4 teenagers, right? So doesn't it sound like 3/4 y equals to z, right? I mean, that's the way it sounds. Here's what I mean by flip it. You're going to put the 3/4, you're going to put it on the z, right? And again, I think the word flip it is not the correct word to use there, but that was a word that came to my mind when I was doing this PowerPoint. So again, you write it how it sounds, and then you put the coefficient on the other variable on the other side of the equal sign. Now that's equation number 3, but now I have to put it in proper form, right? I have to put all the variables on the left side and the constant on the right side. So multiply both sides by 4 to get rid of the fractions. Then I subtract 3z from both sides. So I have 4y minus 3z equals to 0. That's equation number 3. Okay. Now you can try it, right? You can try this one. This should be my answer. Okay. Now I'm going to do it, but I'm not going to do it by matrix. I'm going to do it the other way. Remember when you have 1 and 2, get rid of the x's, and 1 and 3, get rid of the x's also. I'm going to use it. I'm going to use that method. Remember, I need to multiply this one by -5. When I multiply -5 times every term, this is what it gives us. Now I add them right, so it's going to give us -2y plus minus 3z equals to -900. That's my new equation number 2. Equation number 3, right, is said with no x, so we can skip that part, right, because there's already a 0 there. So we get my new equation 2 and the equation 3. Now the y, so I'm going to multiply equation number 1 by 2. Why 2? Because 2 times -2 will give us -4, and when I add it to 4, they'll be eliminated. So we get -9z equals to -1800. We divide both sides by -9. So z equals to 200. Now I'm going to go back, right? I'm going to use the new equation 2. So I'm going to go back into equation 2 and plug in 200 for z. This gives us -2y minus 600 equals to -900. So we add 600 to both sides. So we get 300, -300. Why do we divide both sides by -2? We get y equals to 150. So I already have the z and the y. So I'm going to plug it in equation number 1. Y is 150 and z is 200. Right? So x plus 350 equals to 570. We subtract 350 to both sides. And I found the variable x is equal to 200. Remember, the x were adults, the y was teenagers, and the z was preteen. So the answer will be, let me go back real quick. The answer was going to be 200 adults, 220 adults, 150 teenagers, and 200 preteens. That's how we work these type of problems. Hey guys, do you have any questions? At times, students don't have no questions because they don't know what to ask, because this is something new, right? So, hey guys, so please go over the presentation because it was recorded, and see if you can actually follow it, and actually maybe you can do the last one, right? Instead of doing it that way, do it by the matrix form and see if you can come up with it. I want to thank you for joining in my presentation today. and hopefully you come back next week. Thank you.
Thank you so much, Mr. Sasi, for your presentation. So again, yeah, we do want to remind you guys about the previously recorded sessions, which are available on the YouTube playlist. And this session will be available on that playlist later today. Also linked earlier was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey. And before you all leave, I want to share the TVE sessions that we will have next week. At 1 p.m. today, we will have a presentation on degree plans with Debbie Santana and Mary Favela. And next week, we will be back with Happy Math Hour at 11 a.m., where Math 1314 will cover exponential and logarithmic functions, and Math 1324 will cover basic matrix operations and inverses. Our 1 p.m. session next week will be Getting Involved in EPCC Clubs by faculty sponsors. Thank you all for coming in today. We hope you all have a lovely weekend, and if anybody has any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour. Thank you, everybody.